All right, we're back. We are Game 2005. That's Game Physics in the fall 2018 semester at George Brown. And it's week 13, part 2 of our broadcast. We're talking about simple collision detection, this time with SDL. And we're downloading our SDL template version 3. I'm just going to change the resolution of my crazy screen here. And I will clean it up, I swear, one day, to something that is a little bit easier to see on the broadcast. There we go. So what I've done is with this new template, I'm just going to go into it right now. I'm going to just double click on template.sln. And with this template, you're going to see a couple of changes. One is I've added a sound manager, which we're not going to do this week, but I've kind of put in for next week. And next week, I'm going to add a couple more things to give you a complete template. All right, so let's take a look at what I got. First of all, whenever you grab this template, first thing to do is go to X, where it says x64, and change it to x86, because that's what I've configured right now. You can always configure x64 later for yourselves if you want to. Next, you want to retarget your solution. So under either the solution itself, this one, or the template, if you right-click, and if you go retarget, retarget solution if you're on the solution, or retarget project if you're on the project, you need to click retarget. When you do that, you're going to be presented with one or more SDKs for Windows. You want to choose the latest one or the one that works for you and press OK. Once you've done that and you've retargeted, you should try and run the solution by pressing our play button, our build and run button. And once we've done that, you should see a very simple screen that comes up that allows our player's plane, our player's sprite, to animate according to where we are, where our mouse is. That's what's happening. So when I move my mouse right and left, you can see the plane move right and left. Do you see that? Good. All right, so that's the first part, making your template work. And like I said earlier, you're going to be using a version of this template for your final test. All right, so it's 2 short weeks from now, actually, when we do our test. So next week, we're going to do one more lecture, the last lecture next week, which is all around collision response. And we'll do more of SDL stuff in class. But then we're going to have some stuff that we're going to do on our test. You're going to have an hour and a half to produce something based on the template I give you. Okay, so the template I'm going to give you is very similar to what you're seeing here. So it's not like you're never going to see it again. And the task has to be fairly simple because you only have an hour and a half, right? So that's why I'm kind of building you guys up so that it's easier for you guys to do the test, right? And no, I'm not going to update Visual Studio. That is a bad decision right now. Okay, so yes, we've downloaded the template from Blackboard, and now we're ready to the next part. So we need to talk about what's in this template. What we've added is this thing called the Sound Manager. And the Sound Manager has 2 sound types. We're using an enumeration here for the sound type. One of them is music, and another one is sound effects, which is a clip. The way we use the enumeration, or an enum, right, is we take the enumeration name, sound type, and we use the accessor, this kind of double colon accessor, to access that particular enumeration. So if I go to my soundmanager.cpp, if I want to use, depending on the enumeration, I can play a sound, whether it's either a music extension or something like a clip, an audio clip. I can do either one based on the sound effect. Okay, so look, you can see that if my type is equal to sound music, then I'm going to use this thing and play load a music, base file. If my sound is of type sound effects, then I'm going to load a wave file, which is slightly different. These 2 things will work with OGG files, OGG files, and WAV files. The music will also work with MP3 files, if I'm not wrong. Right? So you can play MP3 music, but you can only play OGG or WAV clips, which is really weird, right? But anyways, it's kind of interesting. And this is coming from SDL Mixer. SDL Mixer is another extension for SDL. So if you look at the soundmanager.h, you can see that SDL Mixer has been included, okay? So we're not doing it this week. I'm just mentioning that it's part of your template. That's what I've added. A couple of other things that I've done is I've regulated our, in the main, I've regulated our game loop. Here's the game loop, the while loop. And what I've done here is I'm using a frame start, and this is, again, from the book that I've been referencing, where my frame start is an integer value. And what it does is I have set up a frame rate of 60 frames per second and a delay time of 1,000 divided by 60 frames per second, which works out to be 16.666 milliseconds each frame. That's how long each frame is, 16.66 milliseconds. So I start off by saying, okay, well, frame start is equal to SDL get ticks. I'm getting the frame, that particular set of milliseconds, right? I do my handle events, my update, and my renderer. And then when I do these things, in the frame time, I calculate, I take another SDL get ticks, right? So between these two things, minus the frame start. And if the frame time, which is really delta time, if my delta time, right, is less than the delay time, which is 16 milliseconds, then I wait. And I wait, when I use SDL delay, it actually pauses everything for a short period of time until it meets the 16.666 millisecond mark. So I actually physically wait in my loop for exactly or almost exactly 16.66 milliseconds, which makes it so that I have a controlled loop, right? I've limited my frame rate so that I have a steady beat for my game, okay? That's what's happening here. So that's the second change. The third change is the way I'm moving my player. So if you look at my game.h, my game.h has a couple things, right? What we've done here is we have a couple of functions, the render, the update, the handle events function, and the clean function. And in the handle events function, if I was to look in there, I have the way we handle events in SDL is pretty simple, actually. We say SDL poll event, and we can, poll for any kind of event. That means mouse clicks, joystick events, and mouse movement events. And I'm looking for mouse motion here. So SDL mouse motion is an enumeration, an enum that comes with SDL itself. And what I'm doing is I'm listening for mouse motion, and I'm assigning a couple of new variables that are part of the game class, right? Mouse motion.x and mouse position.y, and I'm assigning event.motion.x, so the event itself, right? And motion.x and motion.y to these two things. So I'm capturing the mouse movements at the x and y position of the mouse every frame. That's what I'm doing, okay? Now that I have the mouse movements, I can assign those x and y positions to the player's position, right? So if you look at the player object under the player.cpp, the player.cpp, what it does is every frame on update, I get the mouse position, right, from the game, that's on line 25 of the player.cpp, and I assign the mouse position to the player's position. But I only care about the y position, the x position of the mouse. Here's the mouse vector. I don't care about the y position because if you notice in the constructor for the player on line 7, I fixed the player's position on the y-axis at 430 pixels. How do I know that? Well, I've done this game a few times, right? So 430 pixels is the right number, okay? It's a number that I know. So could you make this another number? Absolutely, you can figure this out. The other thing I've done is in the texture manager, if you look at texture manager.h, texture manager.h now has 2 overloaded functions for each of the draw and the draw frame. So what I've done with draw is I've given the ability for me to draw an object centered, right? Because by default, objects are drawn on the top left corner of the screen, top left corner of the object, right? So the pivot is the top left corner of the object, but that makes it difficult for me to move things around without offsetting the object. So I use an overloaded draw function that actually centers the object, so the pivot is in the middle, right? And so when I move the object around, if the pivot is in the middle, the object is drawn around my pivot, right? So it's centered. So if you notice in the mouse, in the player position, here's the player position. I do apologize for the noise this morning. If you look at the player's position, notice that the mouse is centered exactly on the player object, right? Because the way I'm drawing the player every frame. Okay, now this is an option that I've given it. So if you notice, and if I look at the draw function here, there's two of them. One of them just takes width and height and so on, and the other one automatically centers it, and well, actually, it centers it as false. It doesn't automatically center it. But if I choose to center it, then the function itself, which I've defined inside of the texture manager.cpp. So if I go to definition, you can see that for this particular function where it's asking if it's centered or not, when I center it, if I decide to center it, if I say if centered, then I choose to create an offset every frame so that the object is centered. Okay, that's all you have to know. So that's what I've done there too. So I've centered the object. The other thing I've also done here is in my draw function, I don't ask for width and height. Before I was asking for width and height, but I should know my own width and height. So what I've done for the player object, again, these are all little changes that I've made. In my player object, in my player.cpp, if you look there again, under line number 9 on the player.cpp, you can see that I have some examples of getting the texture size of the player. So I have the player texture, and what I've done is I've added a new get texture size in the texture manager, which returns the size of my texture in terms of width and height. And now that I have that, I assign my width and my height for my player automatically when I load my new texture. Okay? So that way, whatever the size of the texture is, an example of the player, the texture is 65 pixels by 65 pixels, right? So then I set the width and height automatically when I create my player for the first time. And I need to do this for collision detection because I need to know the size of my bounding box. Okay? So any questions around the change I made? Main.cpp is not the one I'm on. I'm on actually player.cpp right now. You know, player.cpp on the right. And I'm looking at it by here, player.cpp. Right? So, like I said, so I've made a couple of changes so that this thing can run. Okay, now here's the challenge today. I want you guys to help me make an enemy class, or sorry, not an enemy class, another sprite class that we're going to be calling Island. The Island texture is already inside of your assets textures, right? It's island.png, okay? What we're going to do with this island is I want the island to be reused. I don't want to instantiate and destroy islands. once I instantiate the island the first time, it's going to start off screen. It's going to come down the screen, 5 pixels per frame. And when it gets to the bottom of the screen, I want it to reset to the top. And I want to keep doing that over and over again, okay? And then we're going to use this object to collide with the player object. Now, the reason I'm asking you to create the new class is because I want you guys to get familiar with the framework that we're creating here. And I think it's good for you guys to know how to do, new objects, because on your final test, I'm going to probably ask you to do something like that. Make an object, collide with this one, that kind of thing. Okay, here we go. So first things first, how do we do this? If I want to make a new island class, I need to start my framework off right. And I'm going to go to my Solution Explorer here, and I need to discuss how to do this. So one is, I could right-click on my header, and I could say something like add new item. And if you remember how we did this last time, remember that by default, unfortunately, the way I've set it up is that it looks inside of the template folder. That's wrong, right? We want this to look inside of the template SRC folder. So we need to change that folder, the default folder that's looking into, to that folder. So it's got to look at template SRC, right? Now, when I add a new header file, I want to call it island. So let's do that. So we'll say island.h, and we'll add that in. It's going to go in the right place. And then the same thing goes with my island.cpt. I'm going to right-click on my source files. I'm going to add a new item. I'm going to make sure that it's in the right place, and it will be because it remembers template SRC, right? I'm going to click on CPP, and I'm going to put in island.cpp. In my island.cpp class, or my object, right? I'm going to put an include that includes island.h. That's important. Okay, and then I'm going to switch back to my island.h and start coding my class. Okay, just like before, what I want to do, like I did my player, I have this if not defined stuff. These are preprocessor commands, right? I want to capture these if not defined stuff from my island too. So I'm going to copy these ones from my player, put them inside my island on the top, and just rename them to island. Okay, save this some typing. We use this to detect if the island has been defined or not. We close this off. If you look at the player.h, on the bottom, it has this end if. And we're going to close off these this area that we're creating in the island.h by end if. If we've defined the island, we're going to kind of have everything that's inside here defined within these two areas here, right? Between the if not defined and the end if. Okay, cool. Now that we've done this, what we want to do is we know that island will be inheriting from the GameObject superclass. So I need to include this. So I'm going to have to say something like include GameObject.h. Okay? And then what I want to do is create my class, which is island, which inherits from or extends, that's the colon, extends GameObject, right, which is a superclass, but we need to make it public. That is the default way we do that thing in C++. It requires public if we want to use this thing somewhere else. And we're going to have two sections, a public section and a private section of our class. Well, think about these as access areas, right, if you will. So public and private. Okay, cool. Now remember, because we're inheriting from GameObject, we also know that I have a couple of things that I'm inheriting from GameObject, right? By default. Remember last week we talked about our GameObject.h has these abstract virtual functions that we're inheriting from. Void, draw, update, and clean, right? In order for us to make our island class work, we must override these methods. We must define and override them. If we don't, our island class will never work because we're inheriting from an abstract superclass. Okay, this is really cool. But is there a quick way of doing it? And maybe there is. If I go to our island.h, and if I right-click on my GameObject, if I go to quick actions and refactorings here on the top, instead of me typing stuff, I can go to implement pure virtuals for base GameObject. If I click this, right? What it does is it grabs those three virtual functions, island, draw, update, and clean, implements them. So there they are, right? Notice that it makes them private by default. It puts them in the private section. I don't want to make these private. I'd like to make these public. Just move them into the public section, right? But it actually does some of our work for us, which is really, really cool. I like that option a lot, actually. Anything that helps me do coding, right, when it comes to coding quickly is a good option. All right? Does that make sense? Next, I want to also add my public constructor and destructor for the island class. So my constructor looks like this, and my destructor looks like this. Okay? I can use the little light bulb here to create my definition for my constructor. And I can use the light bulb to create my definition for the destructor. So constructor and destructor has been created. All right, I need to do a couple things. I want to move my island, right? I want to move my island. When it goes to the bottom boundary of my screen, I want to check bounds to make sure that it's reached the bottom boundary. And if it's reached the bottom boundary, I want to reset my island. So I need 3 more private functions. I need a move function, I need a check bounds function, and I need a reset function. Those 3 functions, okay? Let's make those in the private area. I'm going to define those 3 functions here. So I'm going to say I need a void. I'm going to use underscore to denote private move, right? I'm going to make a void underscore check bounds. And I'm going to make another void underscore reset. Those are the 3 functions I'm going to use that are new for this particular class, okay? Move, check bounds, and reset. I'm going to define them with my little light bulb. So I'm going to go create definition. Again, create definition. And then the last one, create definition. And once I've done that, I've got all the functions that I need for my game object defined. So some of them are public. And by the way, it says virtual void. I don't need to use a virtual keyword here. I can just define them as void and overwrite the ones that I want. Okay. I've got my functions that are new, that are private, and I've got my destructor and constructor and destructor right here. Again, for those people coming in late, I'm using a new template called template version 3 from Blackboard, right? Remember that I have to switch it to x86, right? And notice it's x86 up here when I use my template. And I've also retargeted my solution. I've gone to my solution, right-clicked, and I chose retarget solution as an example. And then I've chosen the SDK that's for you. Okay, so that's how I made this thing work. Okay, cool. So I've got my island class defined. There it is. But there's nothing that's really done on the island CPP. Let's take a look at island CPP. Okay, so here's my island CPP. Again, all I have here is my constructor and destructor, my draw function, my update function, my clean function, which we haven't done anything with, my move function, my check bounds, and reset. Okay. In my constructor, I want to use a couple of things, right? Whenever I draw something, if we look at the player object as a template, you can see that the player does a couple of things. Player loads the asset, loads the texture, and then it sets the instance for my get texture size, right? Sets my position, sets the width and the height. But I need to do a couple of things. When I load something, I need a reference to the instance, the renderer, okay? And I also need the texture manager. Those 2 things, texture manager and renderer. If I don't have texture manager and renderer, I can't draw anything. So I need a reference to game.h, and I need a reference to texture manager.h, those 2 things, okay? So in island.h, I'm going to put a reference to texture manager. And in island.cpp, I'm going to put a reference to my game.h. When I've done this in my constructor, I can use the texture manager to load. So I'll say the texture manager instance load, and I want to load the file name, which is going to be // assets textures, and then the name of the texture, which is island.png. I'm also going to define, I'm just going to put this on another line so you guys can see it better. I'm also going to define a friendly name for the texture called island, lowercase, and if or not what the renderer is, which is the SDL renderer from our game class. So I'm going to say that the game instance get renderer. Here's my get renderer. That's the renderer from my game class, right? And then I'm also going to go in the island. I got my texture manager, and then I also need to know if it's centered or not. And the answer is going to be true. I'm going to center it. So that is, sorry, let me go back and do that again. If it's flipped or not, and I don't need to do that. I can just cut it off here. Because remember, the load function says I need my file name, my string ID, and the renderer. Those are the three things I need, actually. There we go. Next, instead of me typing in the rest of this stuff, I can go into the player class and grab these three things, these three lines from line 9, 10, and 11 on the player class. I can copy them and copy them into the island.cpp class for now, right? The only thing I need to change is the texture name to island here. By the way, there's another way of doing this, and next week I will have an improvement for the template where you don't have to do any of this stuff. It just does it automatically. But I'm showing you how I can do this way. All right, so cool. We've got my texture manager instance load. I set the width and the height of my island to whatever the texture is. That's what I'm doing here. And once I've done this in my island constructor, I want to draw it. And I can do that in the draw function. So if I go to the draw function, again, I'm going to use the texture manager draw function. I'm going to say that the texture manager, right, instance, draw, and I'm going to draw what? I'm going to draw the island, right? And the island I'm going to draw, I need to know the X and Y coordinates. Here, I'm just going to use the X and Y coordinates of the current X and Y coordinates of the island itself, which are, and by the way, I could use some help here. If I want to do this in multiple lines, I could say that, you know, I can define the X component and the Y component by itself. So I can say something like int X component. I did this a little different than last time. The X component is equal to get position dot X, and Y component, just to give you an idea what that is equal to get position Y. I could do this, and then in here I could pass in the X component and the Y component, right? So I could do that. And then I can pass in the SDL renderer. I'm just going to do this on the next line. I can say the game instance get renderer, right? And if it's centered or not, which is true. It's true. There. Okay, so that will draw my island every frame. And it'll draw it according to which position it's on, X component and Y component. The Y, X, and Y position. I could have done this in one line. I could have taken get position X and put it here, and get position Y and put it here. I just broke it down so you can see it differently. All right, so that draws everything. But remember what I wanted to do. I want to move down the screen 5 pixels per frame. The island's going to move down the screen 5 pixels per frame. So I need to use my move, check bounds, and reset functions that I defined, right? So let's do some pseudocode. I want to, in my update function, I want to move down the screen 5 pixels per frame. That's what I want to do. When the island reaches the bottom boundary, I'll say instead of reaches, we'll say passes the bottom boundary, then reset. That's what I want to do, right? That's what I really want my code to do. How do I do this? Well, I'm going to call the move function, right? And then I'm going to call the check bounds function. That's what I wanted to do. Okay. I can take away this. This is just my pseudocode. Okay, well, I'm going to move 5 pixels per frame, but I have no way of doing that. I want to use the velocity of my object, right? Except I don't have access to the velocity because I haven't made that available in my game object. So what I do is I can go back to Solution Explorer, go to my game object.h, and start defining some additional getters and setters. All right, so notice I can get the velocity, but I can't set the velocity. I need to do that. So I'm going to go here in my setters, in my GameObject.h, and say void set velocity. And I'm going to set the velocity to a new GLM vec2 object called new velocity. Okay, good. So there's my velocity. I'm setting my velocity. You know what? I also, in the future, I'm also going to need to, while I'm here, I also need to get width and get height. I'm going to need to do that. So I might as well make getters for this as well. So in the getter section, I'm going to need to return a width and a height, which are going to be integers. So get width and int get height. I need to do both of those things. Int get width and get height. And those get width and get heights and set velocity are the three new things I want to add into my class right now. So again, I'm going to use the little quick light bulb to do this. I'm going to kind of create my definition for get width. We're going to come here a couple times today and get height. And I'm also going to set velocity, right? So I'm going to kind of create all these little things here. Cool. All right. Again, just to reiterate what I talked about last week, we're creating a monolithic game object class that every other game object is inheriting from. Is this great practice? For a simple game, okay. More complex games, no, right? But this is okay for us. All right, so yeah, we have get width and get height and set height and velocity and all that stuff. We're kind of doing all those things. Let's define them. So I'm going to go into my GameObject.cpp and define that stuff. So in a GameObject.cpp file, we have some additional things to define. One of them is this get height and get width, which we're going to return m_width. And for get height, we're going to return m_height. There's our getters. And then for setting velocity, which is down here, we're going to say that m_velocity is equal to the new velocity, whatever that is. Okay. Okay, question for you, is this great practice? We're actually having a velocity object, which is a GLM vec2 object, and we're setting it to this new velocity. What's happening here? Well, what's actually happening is we're creating a copy of the new velocity object, which is of type GLM vec2, right? So that whole object is being copied onto the stack, right? And passed into our function as a parameter, right? So when we get this thing as a parameter, we use it, we set it, the values of it to the new velocity, the velocity, and then after the function is done, it, automatic garbage collection comes around and garbage collects everything that's on the stack when it returns. Okay. So it's a temporary bump in memory, kind of adds memory and subtracts it right away. Now this is okay for small methods like this, but what if I was passing a whole other class? That would be bad. We would do a reference as opposed to a copy. This is a copy. This is okay, but for something bigger, references are better. Okay, cool. So we've done this part. Now we can go back to our island CPP because I want to move in check bounds. I want to set a couple of things here at the top. In my island constructor, I want to set my velocity now to a new GLM vec2 object, right? GLM vec2, and I'm passing in an x and y coordinate, my velocity. The x on the x-axis, I don't want to have a velocity, so I'm going to pass in 0. On the y-axis, I'm going to pass in 5 pixels per frame, right? So this is going to actually move us down the y-axis 5 pixels per frame when I set my velocity, all right? Now, right now, the way setting my velocity works is I'm not actually using it as velocity, more as speed, okay? I'm calling it velocity, but actually it's being speed. It's like speed because I'm not pushing the object. It's not being pushed with gravity or anything like that. There's no physics associated with it. It's just going to give me a motion downwards, okay? So now in my move function, what I want to do is I want to say that I want to set position. I'm going to set my position of my object, whatever the new position is. But the new position is going to be, I'm going to add my current position plus my velocity every frame, okay? So let's break it down to a couple of lines. I could say that I want to add those two things. Now, can I add two GLM vec2s? Can I say something like GLM vec2 new position, right, as an example, is equal to my current position, or get position. Could I do this plus get velocity? Could I do that? Right? Can I add two vectors like that? And yeah, this is okay to do, right? Because I'm getting the position here and the velocity, and I'm setting it to new position. The plus operator is functional for two GLM-vec2s, right? My position is X and Y coordinates. My velocity is X and Y coordinates. I'm adding them together to get a new position, right? Which is of type GLM-vec2, X and Y coordinates. And here what I can do is I can set my position to my new position, whatever that is. Just adding my velocity to the position. This is a little different in the previous tutorial. Okay, cool. So that's my move. But now what I do is I move down, and then I want to check bounds to see if I've gotten to the bottom of the screen. So I want to say that if my position on the y-axis is greater than 480 pixels, which is the height of the screen, plus my height, my full height of my object, then I want to do something called reset. Okay, so I want to reset my object back to the top of the screen somewhere, and when I reset it, I want to randomly generate the position that the island is going to appear in on the x-axis. I don't want the island to appear in the same position. That's too boring. I want to reset it so it looks like another island, something else that's coming down the screen. Okay, so my check bounds function, which is going to be called here, so move first, then check bounds, see if I've reached the bottom, and then a reset. My reset is going to work like this. I'm going to say that upon reset, I'm going to do a couple things. One, I'm going to set my position on the x-axis. It's going to be a random x position, and on the y-axis, it's going to be a set position. So let's do these things. Let's break it down here. Int, again, we'll do x component, and then int y component. And my x component is going to be random. We're going to use rand, right? Percent 640, right? And then we're going to add 1 to it. And I'm going to come back to this in a second. And in my y component, it's going to be the negative height of my object. So negative get height. This is going to make sure that my object goes off screen the full way, okay? But here we have a bit of a problem. If we just do this random number between 1 and 640, right? This is bad because what's going to happen is our object is going to be literally half off the screen, either on the beginning or the end, because, like I mentioned earlier, our object is centered. That means it's being drawn around my center point, right? That means it might be half off the screen. So to compensate for that, I'm going to subtract the total width of the object. So I'm going to take 640. I'm going to subtract the width of the object. Okay? And then I'm going to add half of it back in. So I could also define that int half width is equal to, get width times 0.5. That's what I'm doing. Notice I'm not dividing, but I'm actually multiplying by 0.5. It's more efficient still. So I want to do this, rand 640 minus get width, and then plus half my width, which is this. So plus half width, and then plus 1. Okay, now this goes from kind of a 1, maybe I could even go from 0, but from 1 to 640, and then I'm adjusting, I'm offsetting the random number by the width of the object, one way or the other. All right, cool. So now that I've got this, I can pass these two things, my x component and my y component, into the new position. But I need to pass these in as a new GLM-vec2 object. So I'm going to kind of do one of these. And there we go. There we have it. Okay, so this is the new position. I'm going to reset to this position after I come to the bottom of the screen. By the way, could I overload my set position to take different kinds of values, a GLM-vec2? Could I actually add the equals operator, overload the equals operator? So I can say that one thing is equal to another thing, I could. So instead of just passing in a vec2, could I pass in x and y coordinates instead? I could, right? Lots of things I could do here to make my functions, my utility functions better. And maybe next week, what I'll do is I'll present another version of my template that has these overloads to give you guys some conveniences. That's all it's going to be, right? Okay, cool. So half width, half height, and all this kind of stuff is things that we needed, but we did the half width part. And it's not something that's being saved in my game object. Maybe next week what I'll do is I'll compute half width and half height for you automatically, so you have a half width and half height value that I don't have to do every frame, every time I update. It'll just always be there. I always know what my half width and half height is if I use it regularly. Okay, cool. So that's something we can do. So now that I've done this reset, one thing I need to do is when I instantiate my island for the first time, I want to reset its position right away. So I'm going to say something like underscore reset. Okay, cool. And that, my friends, is my island class. My island class starts off, I instantiate it, I load my island. Then what I do is I get the size of my island, x and y coordinates. I set the velocity of 5 pixels per frame downwards. I reset my island back to the position off screen, right? And then every frame I'll draw my island in its new position, x component and y component. That's what's going to happen. I'm going to, in my update function, I'm going to move my island and check the boundary to see if I've reached the bottom of the boundary. In the move, I'm going to calculate the new position by adding the velocity to the position, the current position, right? And setting a new position variable right here. And then in my checkbounds function, I'm going to get the position on the y-axis, only see if it's greater than the bottom of the screen and the height of the object combined. And if it's true, I'm going to reset it back to, in the reset function, off screen, a negative height, so on the y component, and some random position along the top of the screen on the x component. That's what's happening. Okay, cool. Are we done yet? No, we're not. We need to use this new island class in my game.h, in my game class. Okay, so let me go back to my game.h. There's my game.h. And notice that I have a reference on the bottom here to my player. Let's make an area here that says, game objects. Here's all my game objects. One of them is player, and the other one is going to be island. So here's my island. I'm going to make a reference to the island as a pointer, m_p island. Okay, there it is. And what I want to do here is I want to update each of the islands that I have on my screen. I'm only going to have one, but this is going to create a reference to a new one. And if I go to my island, my game.cpp now, so let's go there, game.cpp. We notice that we're instantiating our game objects here in create game objects. We talked about this last time, that we can't do it on our constructor because the renderer has not been created yet, so we can't do it here. We need to do it when everything has been created, the window, the render, the surface, all that stuff. So here we're going to say m_p island is equal to a new island. And when we use the new keyword, we set aside memory on the heap for this new object. Okay, well, the reason why it's giving me this error is because in my game.h on the top, I haven't included the island class, which I need to do. So I include island.h. All right. Here we go. And you can see that I have a new player, a new island. And then when I scroll down, in my render function where I draw stuff, this is interesting. Just like other frameworks, it's going to layer things in drawing order. So if I draw my island first, it's going to layer it underneath my player object. If I draw my player first, it's going to layer it underneath my island. The plane under the island doesn't make any sense. So we have to draw the island first. All right, so we're going to do that. m_p island. And then we're going to say draw. We're going to draw the island first, then the player. And then we're also going to update. It doesn't matter the order here. m_p island update. All right, that's pretty cool. I've got the island and the player updating. Now, if you notice that there's some kind of duplication here, and also I'm updating and drawing each individual game object. What would be nice is if I had something called a display list of game objects that I could add. I have a display list, and the display list is something that I update and draw every frame. Okay, so I don't have to do individual things. I can just go through each item in the display list in a for loop, draw each item, go through each item in the display list, and update each item. Okay, and I think that's better than doing it this way. The problem is, and here's the challenge, I have to make sure that if I had a display list or something like that, then I would have to draw them in the right order. Otherwise, I'm going to have some weird drawing order. Okay, cool. So we've got this. We got the draw and update. And then I have a clean, which I'm going to update at some other point in the future, probably next week. And this should be enough to run my program. So this is what it should be like now. Let's take a look. If I didn't make a mistake, what we should be able to see is an island randomly generating at the top of my screen somewhere and resetting randomly all the time. This is what you should have now. I'll get some random location for the island, and it looks like it's passing underneath the player because of the drawing order, right? And now we're able to do collisions, which is what we're here for in the first place. This is what this thing is all about. I want to do collisions, okay? So in order for me to do collisions, and by the way, guys, if you came in late, I do have a GitHub repo that I've already made from our lab on Tuesday. It's on github.com/George Brown College, and then /GAME2005 F2018 -lesson13. Right. So if you actually go there on GitHub, you'll see all the code for this, the finalized, or the final version of our code is there already for you. Okay, so it's not like if you missed it, you're missing it. You have it. Okay. I recommend also if you miss class, you can always watch the video that's up on YouTube that I'm recording right now. But right now, all we have is this little island, and I have my plane, and I can go over it. It looks like I'm going over it, but I want to be able to collide with this island. Maybe the game, and the game I normally make is something called Mail Pilot. When I go over the island, I collect mail, and I get points. Yay! I can't collect points unless I can detect that I'm colliding with the island, though, right? So let's do the collision detection now. I'm going to just briefly pause the video here so I can get everyone on board that's in the class. Otherwise, you're going to miss this really crucial part, right? And then that would be bad. I think I want you guys to do this. If you don't do this, then when it comes to your test, you're going to be in trouble, right? So let's pause the video at this point, and I'm going to get you guys, I should try and get you guys all up to speed within about 5 or 10 minutes, okay? And we'll come back, and I'll create the new collision manager class that we're going to use to check collisions, okay?